Very excited on the Big Idea podcast today to have one of my good friends, Dr. Vijay Mahant. Dr. Mahant is a brilliant scientist. He did his postdoc actually at MD Anderson. He has invented multiple diagnostics, has about 30 patents last time I looked that you I believe, got approved, uh, and just a genius in the field. Brilliant geneticist, uh, leader in liquid biopsy. Dr. Mahant, thanks for coming on the Big Idea podcast.
First of all, thank you very much. I would like to thank everybody. It's a pleasure and an honor to join this. And without the patients, the audience, we would not be having this discussion. And I would like to thank you for an opportunity to invite me to
Yeah,
participate in this. Thank you
absolutely.
very much.
Absolutely. Thank you, Vijay. And for those of you that don't know, Dr. Mahant actually is on the scientific advisory board of CHIPSA Hospital, and he's also the vice president of precision medicine for United Cancer Center. So we have a great relationship, uh, just an incredible resource and scientific mind. So thank you for that. And one thing that I know that you wanted to go over, and I'll say it here, and you can add anything. We're not giving any medical advice on this.
Yes.
We're just giving information as we have it from your expertise. What exactly would you like to fill in before we really get started?
Yeah, it's just a general disclaimer that I would like to get out of the way as a formality. So I, Vijay Mahan, expressly disclaims any and all liability or responsibility for any direct, indirect, incidental, special, consequential, or other damages arising out of any individual's use or reference to, reliance on, or inability to use this podcast or the information presented in this podcast. So thank you.
All
That's it.
right. Thank you for that, VJ. So, tell us, like, we're going to get into a few different things right now. Obviously, right now, we have COVID-19 stuff going on, and we have a lot of uncertainty really in the world. You're actually working on multiple diagnostics in that realm and consulting. And I'm actually not, we'll go into all the things that you're doing. But before we do that, let's talk a little bit about some different cancer ideas, cancer treatment ideas that you've had. You're vice president of precision medicine for United Cancer Centers, on the scientific advisory board for CHIPSA. Um, Talk a little bit about precision medicine in oncology and how you match specific drugs with the genetics of the patients.
Okay, a great question, Ed. First of all, we do look at the genetics and see, based on the genes, whether that particular drug would be beneficial or have some side effects. And we can mitigate those based on the genetics. So for example, if somebody has certain mutations, the drug may not be metabolized. It may have cardiotoxicity, for example. And a lot of the chemos are well known to have cardiotoxicity, renal toxicity, and so forth. Doxorubicin is one example. Not every patient has it, but those who have certain mutations in their genes will be at high risk of developing side effects. So what we do is basically we can determine if the drug is going to be suitable for each patient. And we can also dial in the dose as well. Not only that we look for whether the drug is suitable, but what dose would it be suitable? I hope that answers that question.
Yeah, no, that absolutely does. And, they're able to do that with, multiple different medications. Right now, you can do a PGX test.
Yes.
You can sequence the gut microbiome. You're actually a leader in the importance of the gut microbiome for different ailments. I know that you've been working on that for a while. You can do it for picking um, different chemotherapies or immunotherapies. Um,
Yes.
when, like, one of the things we're working on with United Cancer Centers is actually taking all of that into consideration, the research tools and the diagnostics, and making informed decisions with all of the information that we have. But for those that don't really know that a lot of those tests are out there, at least as research tools, talk about that.
Yeah, yeah, those are all good points. And the third element is also epigenetics as well, your nutrition, which
Yes.
plays a critical role actually, not only in the microbiome, but also how those drugs actually might interact, positively or negatively as well, with depending on the diet you're taking or consuming. So epigenetics also plays a critical role as well. So we look at, combining a diagnostic with a therapeutic, but also epigenetics as well, including the nutraceutical area, nutrigenomics as well. So there are a lot of different, it's like an ecosystem. This might help you 50%, the other might help you 20%. So it's the synergy. It's like an orchestra, okay? So different instruments, playing together but they have to play in harmony. That's the key
Yeah.
there. Yeah.
Well, yeah, and you have a lot of experience with that. Talk a little bit about the gut microbiome, because it's just now. When I say just now, I mean the last 5 years or so being recognized as something that's important to focus on. What's your opinion on where that field is going and what patients can do to possibly support their gut immune health?
Yeah, yeah, good question. Diet obviously plays a very critical role. If you're eating a lot of the fast food, it's going to impact your microbiome as well. Most of the time, it's very negative. So developing a healthy microbiome is very critical, okay, generally for general health. And if you have a certain disease, such as cancer, we'll focus on cancer here, it even plays a more important role because your gut has almost 80% of your immune system there, okay? And your microbiome interacts with it, okay?
Right,
It
so
plays
just
a
to
very
repeat,
critical role,
the gut has 80%
almost
of the immune
80%.
system. Wow.
Yes, yeah,
Okay. Yeah.
almost.
Keep going. Sorry, I just wanted to point that.
And secondly, what at the last ESCO meeting, which is like the Olympics of oncology, at the last ESCO meeting, most of the presentation focused on microbiome and checkpoint inhibitors. So there is a lot of interest, growing interest in combining.
The two.
What they're finding is that it's got a synergistic effect if you combine checkpoint inhibitors with the right microbiome.
Yeah, and for those out there, checkpoint inhibitors are a type of immunotherapy
Yeah,
made popular, I guess, 2018. Basically, won the Nobel Prize in medicine.
yes,
James Allison at MD Anderson for Yervoy, which is
right,
ipilimumab, and the doctor out of Japan for I believe it was PDL1. So like Opdivo, Keytruda. Uh, and that's what Jimmy Carter did, the president of the United States. He did Keytruda for his melanoma.
mhm,
Um, it has saved a lot of lives. We're actually seeing it's an immunotherapy. One of the things, Dr. Mahant, that Dr. Marancola talks about is, yeah, 15 years ago, in many ways, what I was doing wasn't considered real science
yes,
because they didn't really consider immunotherapy a possibility. But now, of course, we're seeing that. I think it's important for those that don't know, the ASCO it's the conventional uh, oncology conference. It's like the big one, and the
it's the
fact that,
Olympics. We call it the Olympics. Yeah,
yeah, the Olympics. There you go.
yeah,
So
yeah,
I mean, for ASCO to
yes,
be focusing on all the studies on the gut microbiome and the interactions with checkpoint inhibitors, that's impressive that it's
yes.
come that far, because there's a lot of people like you have been saying, hey, this is important for a long time, and it's becoming kind of mainstream thought now.
Yes.
Why do you think, what do you think about it, becoming mainstream thought?
The sorry.
Where do you think that people will go with that? Uh, like now that it is kind of mainstream thought that this
Yeah,
does have an effect on uh, the immune response to cancer. Where do you think the field will go with that?
I see. I think there will be more and more of it, and there will be some other strategies coming in, because cancer is a very interesting or a smart disease, as I call it. It's like the ninja. Okay, I call it the ninja sometimes, just to
Yeah,
simplify it. Okay,
yeah.
it hides, it plays a guerrilla warfare. Sometimes it hibernates. Okay, and so you really have to develop a very dynamic approach. You have to be constantly on the toes. It's a moving target, as I mentioned earlier on. So I think one approach might work, two together might have more effect, and three sometimes. And very important, I always stress that, is your lifestyle. For example, I'll tell you why I feel that way. Because if for some reason you're not sleeping well, your diet is really bad, for example, your cortisol level might go up, which will actually suppress your immune system as well. Okay, so if your diet is bad, it's going to impact actually not only your immune system but many other systems. It's like an ecosystem. It's like a ripple effect, and sometimes it's like a tsunami. It's more than a ripple effect. So all these play actually a very important role together, because a lot of the medications, also treatments, have side effects. They come with a price. Okay, so so and there are a lot of other tools which are being developed actually to either manage the disease or to predict what the outcome might be. So there are tools which are being developed, like, for example, the liquid biopsy. There are other tools which are also sometimes called soft biopsy, by the way. I don't know if people are familiar with soft biopsy, and it's particularly used in especially prostate cancer, bladder cancer. So instead of looking at whole blood, looking at the circulating tumor DNA or circulating tumor cells, you're looking at actually the material from urine now. It's called soft biopsy.
Mm,
And there's another one now. It's called breath biopsy, by the way.
really?
Yes,
Breath biopsy. I haven't heard
yes,
of this
breath
one.
biopsy.
How are they doing it?
Because it's actually still very in the early stages, because what happens is that cancer cells have high rate of metabolism. So they produce a lot of the volatile gases. You can actually add certain radioactive materials to make it more sensitive. So for example, let's say a lung cancer might be producing a number of volatile gases, and you can pick those up, actually analyze those. So I think it's a useful tool. It's a supplementary tool. It might be good. In some cases, it's non-invasive. You could actually use it as a screening tool, and with some limitations. Okay, because tumor biology varies a lot, and in some areas you might not be able to pick it up. It may not be sensitive. For example, you may not be able to pick it up if you got prostate cancer or brain cancer at all. I mean, it might be okay if you got oral cancers or lung cancer, but it might be too late. And the tumor biology is so different in different parts of even the same part of the body. Let's say a lung, you might have, 3 or 4 different type of tumor biology going on.
Yeah, gosh, it's so. One of the things you say is cancer is a moving target. And it takes a game plan that uses combination, therapy because you know we really need to get an understanding of the cancer biology,
Yeah,
and it is different and changing. Um, you know, with that understanding, uh, wouldn't it make sense to uh, do things like liquid biopsies kind of more often, like getting a 3-month, 6-month idea to see if if or how things are changing?
I think it will be good for monitoring. Yes, I agree with you, especially in people uh, who might be at higher predisposition, for example, genetic problems, and secondly, if they are going to be monitored on a therapy, I think it's very important tool as well to see if the drug is working, because a lot of the time the drugs stop working as well.
Hmm.
The drugs, uh, the
Yeah,
cells, actually, the tumor cells start developing resistance as well.
sure.
Yeah.
Absolutely.
So I think it's a powerful, good tool to monitor it. And secondly, it might actually mitigate some of the toxicity effects as well. Because if the drug needs to be changed or stopped or the dose needs to be adjusted, it can be done if you monitor it.
Yeah, well, and this is technically a research tool right now. It's not a diagnostic, right? So, we can make adjustments, but is that am I still reading that right?
Yeah. Yes.
Okay. Um, because a lot of people don't understand the difference between research tools and diagnostics, and it's something that I've learned over the years now, kind of how the system works, and I think that there's a place, and I wanted to make this distinction because um, you know research tools have not been FDA approved, but they're tools. You can use a tool in your toolbox. Doesn't mean it's your go-to 100%. Of course, some diagnostics aren't exactly 100%, but it doesn't mean it's your go-to gold standard. It means that you can use it as part of, uh, as a tool to make a better or more informed decision. Why do you think that there hasn't been say a better conversation or more open conversation about this outside of the scientific community? I don't think patients really understand that there's possibilities in this.
Yeah. Okay. Yeah. A good point. First of all, I mean, there are pros and cons. Okay. Because let's look at some of them. One is, for example, it could be a wild west here. I mean, people are trying to make money. The test may not perform, or it might give wrong results, and that could be a
Fair enough.
big problem as well.
Fair enough.
Because not only a person might be treated with a positive, a drug which is going to have bad effects, for example, or negative effects. That's one problem. Okay. The second could be other issues, some ethical issues, moral issues, family issues. So being diagnosed incorrectly can lead into many, many issues. Okay. So secondly, also, it gives actually uh, the regulatory aspect gives actually some sort of guideline, some control. Okay.
Mhm.
uh, and also, I think what it does is it excludes a lot of it filters out a lot of the companies, the ones which does all this work, extensive work, goes through it. But on the other hand, given what's happening now with the pandemic situation, the FDA has actually relaxed a lot of the rules. Okay. So a lot of the tools are being used under the emergency act now, whether it's a drug or a diagnostic tool. So I think given the situation, like the current situation we have, the FDA has actually considered relaxing a lot of the rules and allow them to be used as soon as you at least file the submission. Yeah.
Yeah, well, I guess yeah. My point to that was, there's good and bad with it.
Yes.
If you're using it as a tool, it's not your go-to. We're going to do this, but you're especially if you're doing multiple tests and you take the holistic type look at it. It supports in making a more informed decision.
Decision. Yes.
Um, Going into the COVID-19
Yes.
issues that are going on right now. Obviously, you've invented a lot of diagnostics. Actually, you invented one of the prostate cancer tests a while back. Talk to us
Yeah.
about that.
Yeah.
What did you invent?
Yeah. This was actually a rapid test which can be done in 5 minutes quantitatively. So I developed the technology, got the patent issued did few deals, and set up a company in Carlsbad. So I was the licensor of the technology as well as the chief scientific officer of the company. The name of the company is Qualogen in Carlsbad. So it's a disposable bag, actually. It has all the reagents, and the sample, which is serum or plasma, is added actually to the pouch. And then the instrument actually spits out the results in 5 to 10 minutes, typically, for most of the tests. PSA was one of them, the early one. So we actually approached a lot of the urology markets. We've got a few thousand systems actually worldwide now.
Yeah, that's amazing. You also did. You were a co-founder of Autogenomics. What does Autogenomics do?
Yeah, we started this company about 20 years ago. Initially, our focus was cervical cancer, by the way. So for human papilloma virus, and then we expanded into, this is going back like 18 years, we also went into pharmacogenetics as well. We focused on cardiovascular areas, we focused on oncology, we focused on neurology, we focused on all the psychiatric drugs, and so forth. And then later on, we expanded into women's healthcare as well. And
Gotcha. That's amazing. Talk about okay, COVID-19. So you're an expert at diagnostics. What do people need to know about the current testing for COVID-19?
okay, yeah, good question again. So there are a number of tests actually. It might surprise you that the total number of tests or companies involved right now is like 140. And almost all of them have filed with FDA for emergency use, okay, under the Emergency Use Act. So most of these tests are based on looking at the genetic, the blueprint, the RNA, the ribonucleic acid, because these are RNA viruses. So you are fingerprinting actually at nucleic acid, and you're looking at specific targets, because there are like more than 40 coronaviruses. And the COVID-19, which causes the disease actually, the SARS, is one of the new ones. Although it might have been there, although there is some evidence it was actually present in some of the animals like bats, snakes, and so forth. Now it has actually moved on or transitioned to humans as well, okay? There's still some dispute there. So you need to pick it up very specifically. So most of the companies are focused actually on the molecular diagnostic test. So you're looking at certain specific regions which will target pieces of this particular coronavirus, the 19. So you're picking it up specifically. So most of the tests which have been actually filed with FDA and are being used now worldwide are based on RNA. And then the serological test, which look for your immunoglobulin, IgG, IgM. There has been a little bit of interest. I'll talk a little bit about the pros and cons about the serological test as well.
That's the antibody test, correct?
Yeah, the antibody test, exactly. There are very few of them, and they do have some limitation. They have some utility, I feel. There is some utility there. As long as you understand what the limitations are of the test. So the one which has been gaining actually the most of the momentum is actually the molecular diagnostic test. Abbott recently, about 2 weeks ago, made an announcement for the rapid test. It takes about 5 minutes, according to the company. There are a few other tests which take about anywhere from 45 minutes to about 4 hours, okay? And one of the challenges has been actually specimen collection. Because there are a number of challenges there. One of the challenges there is the integrity of the sample. There are a number of ways to collect the sample. And there are a number of devices which are being used or are available to collect it, through the nose. Those are called nasopharyngeal devices. Then there are oropharyngeal devices as well. And now, more recently, just like 2 days ago, there is a saliva test now. Okay. But like 99% of the collection devices actually use nasopharyngeal because some of the research has demonstrated that the best quality of material is actually using nasopharyngeal. But nasopharyngeal specimen look very attractive in many, many ways and has shown the best results so far. However, there are some issues there. It's not so easy or pleasant to use. Secondly, it produces cough in people. So if you are actually infected with the virus, you might be exposing a lot of people with the cough and so forth. So there are some issues.
Wait, you said it causes a cough using the.
Yes, because you really have to go down through your nostrils, deep into the throat area.
Really?
Okay.
Oh,
Yeah.
that sounds
And
intense.
it is. Yes, it's not very pleasant, and a lot of people tend to produce different responses. Well, some cough and some, you know, are choking basically.
Yeah.
So there are like health hazard issues there. Okay, it exposes the workers, the people in that area as well.
Sure.
Okay, so they have done some studies actually with stools to see if they can find any traces of the virus because it would be a very attractive sample. Okay.
Mm-hmm.
Unfortunately, so far, the results have been negative. Blood, they've tested blood as well. And again, it doesn't show up. At least they haven't, based on what I've seen, no evidence of picking up actually the virus in blood right now.
Mm.
Urine has been tested, again, negative results. What is happening now, very recently, this is actually, I think, going to add more power, are the CT scans, actually, the thoracic CT scans. And in the UK, they're already doing it, actually, some of the radiology labs. What they do is it takes about 5 minutes, by the way.
Mm-hmm.
Okay. And if you're showing anything, they use artificial intelligence. And they send,
So wait, are these X-rays?
yes.
So they're going in. What are they X-raying?
The lungs,
area?
the lungs.
Okay, so they're X-raying the lungs. How do they tell it's COVID from X-raying the lungs?
Because it affects the thoracic, your respiratory system, the heart, and so forth. Okay, you get inflammation, you get pneumonia-like symptoms. Okay?
Sure, but I guess what I'm saying is, couldn't that be something? Would it be a diagnostic, or is it just like give you an idea that they actually have something to really test for?
If there are some signs, they use artificial intelligence and machine learning actually.
Uh-huh.
So they built in really sophisticated software.
Interesting.
Look,
Yeah, I know that we've talked about it a lot, the use of AI in radiology. And there's been some really interesting studies on that. So I guess that's what you're saying. They're doing the X-ray, they're running it
Yes,
through AI. The AI is able to spit out, hey, this is what's going on to a high likelihood.
yes. And what they do is they send it to the hospitals basically, and then they combine it, with a molecular-based test, your molecular diagnostic test. So now they've got more information, by the way.
Mm-hmm.
But what this allows is actually to cut down on some of the screening, a triage. Okay.
Mm-hmm.
So you can, because it's quick, it takes few minutes, less than 5 minutes to do the whole thing. And the data can be sent, actually analyzed, sent. And then if they find anything, those patients can be tested actually with more sophisticated or complementary tests.
Gotcha. Wow. So, I got a question here. You mentioned before that there were some questions about the transmission going from bats to humans, or what animals to humans. Um, you know, I've seen people ask about like a biological weapon if it was made in a lab. Have you read any studies on that? Is that a possibility, or is that just conspiracy?
It's a good question. I think it's still being investigated. But what might be interesting, I don't know if you read a book called, it was written actually 40 years ago as a science fiction. Let me see the name of, let me try to recollect the
Oh, is it
name.
like 1984?
1981, almost 40 years ago.
1984? Yes.
81, I think it
Oh,
was
81.
written. Yeah. Eyes to Darkness or something like that. Let me see if I can pull it up.
Okay.
It was written as a science fiction. And in that book, and I can send you the pages and the title of the book. In that book, it said that in 2020, there will be a virus called the Wuhan 400. Okay.
Wow.
It will have pneumonia-like symptoms.
Wow. That's really weird.
Yes.
That's really weird.
So
What do you think about that?
interesting. I was very, very interesting to, let me see if I can pull up the title here. Give me 1 minute and I will, you can look it up and I can send you the details later on if
Sure.
it is of further interest to anyone. You can send it.
Sure.
So just give me 1 second. I sent it actually to a friend of mine. So he couldn't believe, and I sent it to another one of our scientific advisory board member, Dr. Philip Kim. He was shaking his head too. So let me see if I can pull it up. Just give me 1 second here. Yeah. But go ahead. You can ask me any other question in the meanwhile while I'll pull out the title here.
Yeah, I was pulling it up too. I think it. I just typed in Wuhan 400. Is it the Eyes of Darkness?
Yes.
Yes. Okay. I see. Yeah, it was written in 1981. The
Yes,
Eyes of
1981.
Darkness.
Yes.
And yeah, that's pretty interesting. So if anybody's out there listening, uh, for those of you who are out there listening, it's called Eyes of Darkness. Dean Koontz
Yes.
and
Team. Yes.
yeah, Dr. Mahant saying that I don't have the exact quote, but he was talking about the Wuhan 400. Yeah, the idea, there's a lot of conspiracies out there on many sides, and
Yes.
you're a scientist, so it's like, well, you're a scientist. You look at things with the scientific method, but there are some things that there's a lot of questions with things like that, and when with what's happened in China, it
Yes.
leaves questions because we were left in the dark for a long time about this.
Right.
As soon as January 14th, the World Health Organization tweeted out that the Chinese authorities said that there was not human to human transmission. And then 1 week later, the first patient arrived in the United States. The first person arrived positive in the United States. And so it does make you wonder what's really going on and questioning. And my thing is, questioning is good. We should be questioning everything. We should be looking into everything and not just take everybody's word for it. Dig
Yes.
into the data, dig into the research, and see what it's really saying. Because nobody really, I guess, I was wondering if there were any studies that could prove or disprove it. I know you would know, but I guess nobody knows right now.
Yes. And one of the other problem is that almost 50% of the people who have tested positive, by the way, are asymptomatic.
Mm-hmm.
So there might be a lot of carriers, they just don't have the symptoms. They might develop the symptoms later on.
Yeah, that's a good
You see,
point.
that's another challenge there. Yeah.
That's a very good point. And when we look at these mortality rates as well, actually, we were talking about this on the phone yesterday. When we look at these mortality rates, if 50% are asymptomatic, they're not getting tested. They're not out
Yes.
getting tested. So, I mean, I've read different epidemiological studies that are showing between 10 and 60 times the amount of people have it in their models, which would mean the mortality rate's a lot lower, but that, a lot more people have it. And it's obviously causing havoc in a certain group of patients. And that actually gets me to my next question. Talk about the comorbidities. What are we
Yes.
seeing with comorbidities? Meaning, uh, people that are out there that have another disease or ailment
Correct.
along with the coronavirus.
Yes. So one of the group is actually the cancer patients as well, simply because they tend to develop a lot of fluid as well in some cases. And we know a number of cancers. Ovarian cancer is one example, okay? And secondly, some of the chemos that they take, like doxorubicin, uh, the risk is even higher. It's got cardiotoxicity.
Mhm.
So cancer patients are at high risk. That's so. Secondly, some of them are diabetic as well. Okay, so if you're diabetic, it actually the risk even goes up higher. Okay, another group is actually people who had or who have pulmonary issues, COPD, for example. Okay, is another class of people at high risk as well. People with asthma, people with other pulmonary diseases. Okay. Another group which is at high risk is actually newborn babies, preemies, simply because their organs are still developing. Their immune system hasn't developed much. So they're at very high risk. Their lungs haven't developed fully, so they're at very high risk as well. So people who have cardiovascular issues, they're at very high risk. People who have autoimmune disease, they have high risk as well. Okay. People who are taking certain medications, I gave doxorubicin as one example, other drugs which suppress the immune system, for example. Okay. It might be that they had the transplant or they might have autoimmune diseases like lupus. Okay. They might be on certain type of steroids, for example, which is going to suppress the immune system. So immunocompromised patients are also at very high risk. So AIDS patients would be at a very high risk as well, obviously.
Gotcha.
So
So basically, it's immune compromised patients,
yeah,
patients that uh, might deal with obesity, morbid obesity, um, diabetes. I guess they're seeing it attack the heart, which is interesting.
yeah,
I'm wondering if it's if it's because of the hypoxia. I mean, they're finding right now that these patients they're sitting with their oxygen levels, blood oxygen levels of like 80, but they're
yes.
functioning completely normal. Uh, wouldn't that cause stress on the organs?
Oh, yeah, absolutely, absolutely, yeah. And secondly, also when they have collected the fluids, it actually promotes the growth of microbes or bacteria, secondary infections as well. You see,
Yeah, the first thing I thought of was uh, ozone therapy, which we talked a little bit about that trial that was going on
right?
in Italy. Uh, Other thing I thought of was hyperbaric oxygen. Of course, you can't put everybody in a hyperbaric oxygen chamber. There's not that many hyperbaric oxygen chambers out there, but to oxygenate the blood and tissues, I would think that could work. And then I actually just interviewed another doctor about mesenchymal stem cells as well. Some of the different trials that are going on with that. Those
Yes.
are the three that I've been kind of really interested in more than the hydroxychloroquine and the other ones. Anything that interests you as far as treatments for COVID?
I think there are a number of approaches there. These are different tools. I think the antiviral drugs being developed by a number of companies are very promising, although still it needs more work. Uh, so that's one approach. The other approaches are actually decoys, by the way.
What do you mean?
Decoys, there are some companies, very young biotech companies who are developing actually certain like proteins which
Oh,
will actually be used as a decoy.
oh, interesting.
Okay.
That's like an anti
Yeah.
IL-6. Got it. Yeah,
Yeah.
those are the monoclonal antibodies. Yeah, I saw that anti-IL-6 drug, and correct me if I'm wrong, but basically, when people are a lot of people that are dying of COVID have a cytokine release syndrome, and IL-6 is one of the cytokines that's killing
Yeah.
people. This is blocking that, correct?
Yes. Another approach is actually the new class of vaccines. They're called mRNA vaccines. They can be engineered much, much faster compared to the typical vaccines.
Yeah, that's what
Okay.
a lot of, yeah. So is that what they're working on when they're saying, oh, we can have one in 12 to 18 months?
Yes, in fact, in shorter period, because typically what they're saying is some of these vaccines can be developed in as little time as like 4 to 6 months, okay, compared to much longer period with the conventional. And secondly, here's another reason why they have a great potential. The reason being, if the virus mutates, then the older vaccines, which are typically used actually to kill the virus, may not work because the virus has mutated. And
Sure.
we've seen that with the flu, for example. A
Right.
lot of the time, a lot of these vaccines haven't worked in the past. So they're designing actually very smart vaccines now, which can be engineered, let me put it this way, much, much easily. Okay. And you can scale it up much, much faster.
What do you say though to the people? I mean, because and actually, I'm one of these people that I'm concerned with them rushing just a vaccine in, and just mass vaccinating people without the proper safety. Um, how do we ensure that if we get the vaccine and that we're doing it really fast, how do we ensure that we're able to keep people safe?
Yeah. I mean, yeah, it's a good question. Obviously, we still have to do some studies at least, but then there is the risk. What do you do if you don't treat the patients or people, and especially in a pandemic situation like this? Because right now, if you look at it, according to CDC and WHO, and I checked the numbers today, as okay, there are like 140 countries impacted by the virus.
Mhm.
140. Okay. Secondly, as we speak, there are like about 2 million confirmed cases globally.
Mhm.
Okay. About 120,000 deaths associated with it. Okay. Associated. I use the word very carefully because there are a lot of people who have pre-existing conditions. So the virus might have just accelerated it or might have contributed. Okay.
Mhm.
So there are 120 deaths associated with it. Okay. So it's a matter of taking the risk, and when do you take it? What do you do with it? And then how do you manage it?
Right.
Yeah.
Well,
I mean,
and seeing that, seeing it spreading like it is, um, you know, I also wonder though, what percentage of the population already has it? I mean, uh, if you look at California, it hasn't really spread a lot. There's the Stanford group that is suggesting that it could have already been here for a while. If you look at the Oxford study is suggesting that as well, that a lot more people actually have it. I mean, I've read different reports on what herd immunity will need to be with this, but if does California in many ways already have herd immunity? Is that what's going on? What do you think of the chances of it being much, well, we know it's more widespread, but being almost to the point of herd immunity in certain states?
yeah, I think, yeah, it depends on a number of factors. One is also uh, the social distancing, whether people observe that, respect it, also there are many, many other factors which I think are going to drive it. For example, we're finding that a lot of the hospitals, for example, the healthcare workers are being affected or have it now, okay,
Mhm.
in many of the hospitals. Uh, when they tested actually in New York, the numbers that I saw, that 50% of the people who were tested had actually were positive.
Yeah.
Yeah.
Wow.
So I don't think, first of all, we are using or we don't have the tools, and I don't think we can because it happened in such a short time. We were not prepared. It was a wake up call in one sense.
Sure.
Yeah. And I think we'll be much, much better prepared as well. And it is expected actually that it might come back again. There might be another wave here hitting us in October, November time. And there's also actually a migration of the virus to the southern hemisphere, like Australia, New Zealand, where the weather is actually becoming colder as well. So by October, November time, we might actually, including Europe and many of the other countries, might be hit again with a second wave. And it might last for another three to four cycles before people either develop the immunity or we have enough of the tools like the vaccines to deal with it and to manage it.
Yeah, I've been kind of on the other side in the sense that looking at the response, looking what's happened in gosh, with the country,
Yes,
shutting everything down
yes,
from a standpoint of sure we're able to uh, slow the spread of the virus, flatten the curve, as they say, but is the economic impact being fully
yes,
considered? And what I mean by that, there's studies that show between for every 1% unemployment, 4,000 to 4,500 people die. So if we're going up to the 27 or rather 30% range, that's a 27% increase. It's 110,000 or so extra people dying of that. Um, and so that's been a lot of my concern, seeing the markets tank, seeing the uh,
yes.
people losing their job. How, from a public health standpoint, from a scientific side or medical side, uh, does do you balance that? Because I'm not sure that initially that's been taken into consideration.
Yes, I think it happened so fast. It was very difficult, actually. And some of the countries have taken a different approach. For example, Sweden has taken a different approach, actually.
Mhm.
They made it voluntary, by the way, in Sweden.
They're what?
They've made it voluntary.
Voluntary.
Like,
Okay.
so, yeah. So they're saying their argument, wrong, right, or indifferent, is that people will start developing immunity. Okay.
Right.
And it's part of the process, natural process as well. Okay. And as I said, it's highly debatable.
Yeah.
But that's what is happening in Italy. But I mean, in Sweden, and the other thing I would like to add actually is that again, it's very difficult to dissect it. They're saying that typically you see about 40,000 deaths every year globally due to flu. But because of social distancing as well as traveling, because there are a lot of restrictions on the travel right now, the number of deaths due to flu has come down substantially.
Mhm.
You
Yeah.
see,
Wait, were you saying how many deaths a year globally of the flu?
about 40,000 they said. Yeah,
Okay.
yeah. So that 40,000 actually number is very, very low
Hmm.
because of restrictions on flying and social distancing as well. So it's almost like negligible, that number now.
Right. Right. Right.
Yeah,
Yeah. Well. Yeah.
yeah,
We'll see exactly
yeah,
what happens. And there are different ideas and different views, and it's interesting because in the uh, if you look on the internet, the debates are very polarizing. Like it's almost like um, if you are looking at the economic impact and the economic
yeah,
impact causing poverty and death,
right.
want people to die. Like, no, not at all. Or if you look at it this way, it's like, oh, you just want people to stay home and, forever. It's like, no, we should be having these discussions and debates because it's healthy. This is my opinion.
Yeah,
Ultimately, we
yes,
all want to save as many lives as possible with, and there's just different ways to look at it.
absolutely. I agree with you. I think I think we are learning a little bit more. There has been a lot of panic as well. Sometimes it's got a positive effect, sometimes negative effect. I think we've been hit in such a short period. No one really knew how to deal with a situation like this.
Right.
Yeah.
And we've got to make adjustments. You got to make adjustments once you get the more data in. It's a lot like, uh, when we're treating cancer patients, you got to make the adjustments. If one thing stops working or a show did not be, you got to make an adjustment. Keep that data
Yeah.
coming, and that's the importance too of good data. You were talking as well about the antibody tests, and a lot of people are talking about it, but you know I'm not sure how much we got into it today. Actually, we were talking yesterday and today. So, but we talked yesterday about, people not testing positive for 10 to 14 days with the
Correct.
antibody test. And so that could actually give a false negative if someone were to take it. Is that correct?
Yeah, that's one problem. The other problem is the immunocompromised patients, people who are actually taking drugs to suppress actually the immune system. A lot of people who have like autoimmune diseases, they're taking steroid, for example. As an example, there are a lot of patients on antibody based drugs as well. So their immune system, and as you get older as well, your immune system also goes down.
Mhm.
So
So,
so
so
that's
what you're
another.
saying for people out there, so if you have a suppressed immune system, your
Yeah.
immune system isn't going to be possibly isn't going to be producing the antibodies that a healthy immune system would. So you could get a false negative with that as well, correct?
Yeah, because they're immunocompromised, they may not produce or may produce the antibodies much, much later on. Okay,
Sure.
that's the issue. The drugs actually might have an impact if you're on immunosuppressant where your immune system is suppressed. So they may not be making much of those antibodies. The other problem is the sensitivity of those tests. They're not sensitive enough. Okay. The other problem is the specificity, because they might be picking up other families of the coronaviruses. And they, as I said, there are like more than 40 coronaviruses now.
Mhm. Yeah,
Yeah.
no, yeah. So you're saying that they could test positive for having the coronavirus, the COVID-19 antibodies, but it's really just picking up uh, another coronavirus antibody.
Yeah. But what you could do is to, okay, if you are showing positive, you could actually do your molecular test. Okay. You can do confirmatory tests. You can do the CT scan and so forth. Okay. So you can do follow up. So there is some value.
Sure.
But on the other hand, if you miss it, that patient could actually expose or come
A
in
lot of
contact with a lot
people.
of other people and affect them.
That makes sense.
Yeah.
I mean, there's a lot of variables at play here, and
Yes,
you know, I think that we need to adapt, as fast as we can with the information. I have a concern, as well, that there's bias in a lot of the data that we're getting based on the result uh, people want to get with these numbers. I think that it's become very politicized.
yes,
And so it's so politicized. Let's just say, uh, I actually was debating with somebody today. He messaged me that, well, maybe our economy just isn't set up for this and we should get a new one. And it's like, he was marching us into a complete shut. He wanted to stay shut down for until we have a vaccine, 18 to 24 months. And I mean, the impact would be horrible, in my opinion, overall, if we were to do that. Uh, People would go crazy. Suicide hotlines, by the way, are up 800% as of a report yesterday. So, I mean, people are dealing with mental illnesses and a lot of different things that we got to consider. But
absolutely.
my concern is we have a group on one side that wants the economy to tank, that is marching us into this because they don't like the way the system is. And this could be an excuse for them. And it's not scientific and it's not having the best intentions of society involved. Then you have the other side who, in many ways, believes this is all a complete sham, that, you know, doesn't take it serious, you know, at all whatsoever. And to me, there's kind of room in the middle.
Yes,
There's room in the middle. You can be leaning to a side, fair enough, but so that's kind of my concern with what's going on. Do you see any of that in the
I
scientific?
see a lot of it. Yeah, I do see a lot of it. And I do get a lot of emails or text messages from people about those issues as well. And I agree with you, and we actually resonate. And I say the same thing. I mean, there has to be a middle way, a balance there. These diseases have been around for hundreds of thousands of years, either in animals or in humans. It's not something new. And people have forgotten, by the way, back in 1918, just over 100 years ago, we had the Spanish flu. According to some estimates, about 30 to 35 million people died at that time.
Hmm. Oh,
Okay.
yeah.
And at that time, the population was much smaller compared to today. People didn't travel as much. That's another thing we're not factoring in. And still, 25 to 30 million people in Europe at that time, 100 years ago, that's a lot of people.
It's a lot of people.
Yeah.
No, it's definitely something that we've got to take serious in the sense that we can't just dismiss it to dismiss it because we don't want to believe anything. And on the other hand, it's something that we should definitely dig into the numbers and actually empower ourselves with knowledge and look at the different models. A lot of people think with these epidemiological studies that, you know, they're fact. They're only as good as their assumptions. And you know, there was a big difference if you look at the imperial model, which showed, you know, initially, gosh, I forget how many hundreds of thousands of Americans dying. Maybe it was 2.2 million, 500,000 people in the UK, and then the Oxford model, which was much less. There are two very respected institutions with two very different opinions based on the assumptions that they put into these models. Assumptions are not fact.
Correct.
And I don't think most people realize that.
Yes. No, absolutely. I think we are learning a lot, and people are actually coming out with these different models. And as you said, I think there are a lot of assumptions there, and I think we will have some numbers. I don't know whether it's in 3 months or 6 months, a better arms around it. You know, we'll be able to understand what those numbers are and how do we actually use the data in the future, or artificial intelligence, for example, to come up with better predictions or numbers here.
Yeah, absolutely.
Yeah.
Well, Dr. Mahant, thank you so much for coming on the show today. It's always great to talk to you, and maybe we'll have you on in a couple of weeks from now if we've seen some changes to learn some more.
Thank you. It's been a pleasure and an honor to be here, and I wish everybody a happy day and a safe day as well. So take care, and thank you very much.
Okay. Thank you, Dr. Mahant.
Yeah. Okay. Bye-bye.